Okay, in this video what I'm going to do is go over questions 9 through 19 odd, and several of you missed it in class, so this is for you. So let's just begin with question number 9, and we need to simplify tangent x times cosine x. And the key to simplifying is to inspect it and look for equivalencies, ways you can rewrite it. So I look at this and I see that tangent can be written as sine x over cosine x. And now it is very obvious that you can strike out the cosine x's and you're left with sine x. And that's how it's done. Let's take a look at question number 11. And in question number 11 we see a couple things here. We see secant y, which is a reciprocal identity. And we see the sine of pi over 2 minus y, which is a cofunction identity. So as I maneuver things around, I'm going to start with the equivalency to sine pi over 2 minus y is equal to cosine y. In essence, what that is saying is that the sine ratio of one angle is equal to the cosine ratio of another angle, and of the same triangle, I should say. For example, if you put in your calculator the sine of 50 degrees is equal to the cosine of 40 degrees, and that simply is because once you set those triangles up, those ratios will be the same. And so moving on, we can convert the secant y to its reciprocal equivalent, which is 1 over cosine y, and now it's easy to see that these strike out and your answer is 1. Let's take a look at number 13. In number 13, we have a couple squared trig values, which is oftentimes you want to look at those and see if they are Pythagorean identities of some nature. And so when I look at that, I see 1 plus tangent squared x, which is a derivative of one of the Pythagorean identities that is equivalent to secant squared x. And now what I'm going to do is I'm going to just show you that you can pull these two trig values apart from each other for a minute and then rewrite their reciprocals. So the secant of x, secant squared x is equal to 1 over cosine squared x, and 1 over cosecant squared x is equal to sine squared x. So when I make those replacements, I wind up with the following, which gives me sine squared x over cosine squared x, which is a quotient identity for the tangent squared x. So sometimes you have to jump through several hoops on these, but this is how it's done. Let's take a look at question number 15. With number 15, I see that cosine x presents itself in both terms. So this is a real good candidate for factoring. So when I factor out the cosine x, I'm left with 1 minus cosine squared x, which is one of the derivatives of the Pythagorean identities. So I'll replace that with its equivalent of sine squared x, and that's simply going to be your answer. Once you get it down to sine and cosine, that's basically all you can do. Okay, let's go on to the next page, number 17. And in number 17, we're noting that we have a negative x, and this is a perfect candidate for even and odd functions. We know that cosecant is a reciprocal of sine, and that sine is an odd function. So when you put in a negative x value, you get a negative y value with odd functions. And so I can rewrite that as, first of all, the reciprocal 1 over sine x, but it's also the negative of that because of its odd function attributes. So now as I look at this, I see that it's equal to negative 1. Cotangent, as in similar fashion, is an odd function. So we can rewrite that as negative cotangent x, but again, that's a cotangent can also be expressed as a quotient. And let's look at the cotangent of pi over 2 minus x. That's again a cofunction with tangent. So I'm going to make a couple substitutions here. See if you are okay with this. The cotangent of negative x is equal to negative cotangent x because of the odd function behavior, and the cotangent of 90 minus x, so to speak, is its cofunction tangent. Again, the same relationships going on there as it was with sine and cosine a few problems ago. The cotangent of, let's say, 30 degrees is equivalent to the ratio of tangent of 60 degrees. So we can rewrite those in their equivalent forms. And now we can look at the cotangent as the reciprocal of tan, and our answer is going to be -1. Okay, let's take a look. Well, I guess, I'm sorry, that just concludes this lesson. That's 9 through 19 odd. I hope this was helpful. And if not, then try to come by and see me during long lunch or in period.